It's a polynomial. Show that x plus 1 is a factor. So first part, all I have to do is show that sub x equals minus 1 into there and get 0. And I will give that'll give me minus 1 cubed plus 6 lots of minus 1 squared plus minus 1 minus 4. And that equals minus 1 cubed is minus 1. That'll be plus 6. That'll be minus 1 minus 4. And that equals 0. And therefore x plus 1 is a factor. That's the first part. Part B, I've got to find the exact roots. Well, I now know one of the factors. So first off, I'm going to have to divide it to get that. And I like using the grid method, like so. X plus 1. Let's put plus there, don't need it. And I've got to try and divide that. So it's going to be a quadratic coming in here. So what do I have to multiply x by to get that x cubed? The answer is x squared. So that will give me x cubed. But I've also got to do 1 times x squared. That'll give me 1x squared. I don't want 1x squared. I want plus 5 and plus 6x squared. So I need another 5. So this one's going to have to be plus 5x to give myself that 5x squared here. But that'll also give me 5x times 1 will give me plus 5x. And I don't want to have plus 5x, I only want to have plus 1x, so I'm going to have a minus 4x here, so therefore I'll have to times this by minus 4. And finally, minus 4 times plus 1 gives me minus 4, and that is what I wanted to have at the end, so there we are. So now I know that x plus 1 times by x squared plus 5x minus 4, we're setting that up to equal 0. So either the first one, x plus 1 equals 0, or x squared plus 5x minus 4 equals 0. So x equals negative 1, that's one root, or hopefully this will factorise. X and x, to get 4 this equals 0. To get 4 it's got to be 1 and 4, or 2 and 2. It's negative 4, so one's got to be plus and one's got to be minus. Well, it looks like it's going to be 4 and 1, because that makes 5, but one's positive, one's negative. Doesn't look like it's going to factorise. So I'm going to have to use the formula. So x equals minus b, so that's minus 5, plus or minus the square root. B squared is 25, minus 4 times a is 1, times c is minus 4, all over 2a, so it's all over 2, or 2 times 1. So x equals minus 5 plus or minus the square root of 25 plus 16 is 41 all over 2, and I've got to find the exact roots, so I've got x equals minus 1, or x equals minus 5 minus root 41 over 2, or x equals minus 5 plus root 41 over 2. So it's done the first part. Now part 2, over here. Show that the log that can be written in the form of f of x equals 0. So this shows me I've got to get that to equal 0. So it's going to be all to do with rules of logs. So 2 log to the base 2 of x plus 3 plus log to the base 2 of x minus log to the base 2 of 4x plus 2, that equals 1. Right, first thing, the power bit can go up to the top there, and so that will give me that log of x plus 3 squared. But I'm going to add a log, so therefore that's the same as doing a product, so I could times that by my x, then subtract a log, so that means divide by 4x plus 2. So it's a log of all of that stuff, and that's log to the base 2, and that equals 1. I want to get rid of the log to the base 2, so I'm going to vaporise that by doing the opposite, which means raise it to the power 2, so to it. And that will leave me with x plus 3 squared times x. I can put the x at the front, over 4x plus 2, and that equals, raise the 1 to the power of 2, and that will give me 2, or 2 to the power of 1, which is 2. Now I multiply it all out. That will give me x times x plus 3 squared will be x squared plus 6x plus 9. You could write it out twice if you wanted to. And that is 2 times by 4x plus 2. And that gives me x cubed plus 6x squared plus 9x equals 8x plus 4. And eventually get it all onto one side. That gives me x cubed plus 6x squared plus just the 1x. I'm taking away 8x and then take away 4 as well. Equals 0. And that is what I get, x cubed plus 6x squared. That is correct. So I've done that first bit. And part B, explain why it has only one real root and state the exact value of this root. Well, the middle bit, you've got log to the base 2 of x, and that only exists if x is greater than 0. Okay, therefore x equals -1 and x equals -5 minus root 41 over 2 I'll give it log to base 2x is undefined, so it's meant to be undefined. Therefore x equals half of -5 plus square root of 41, because root 41 is just over 6. That's positive. That is the only thing it could be. And that's question 9 and the whole paper done.